So good morning, everyone. Due to the bulk of participants, we have started the live. And so those who are not able to join this particular meeting, they can continue with the YouTube live. I'm sharing the link and you can pass it to your friends. Thanks to KGISL Institute of Technology. I especially thank all the coordinators as well as staffs of department from Electronics and Communication Engineering. Due to this delay, the time will be matched up by extending this particular time. So now let us start the session. Everyone. Hi everyone. All of you turn off your mic. Okay. So in these sessions we discuss with the WSN, right? Anybody know for then what is a WSN? Hello? Anybody know what is a WSN? Okay. So then what is then in these sessions we discuss with the WSN, right? So first then WSN is one of the part of the embedded system. Okay. So first what is an embedded system?
Wireless sensor network.
Yeah, okay, wireless sensor network. So why using wireless concept are used? Okay, so first discuss with then what is an embedded system. Okay, so in what is an embedded system is its meaning for then first the system. So the system is represent for so to then the a way of working to organizing and then to create the works. Okay, so after to create the works and collecting the all data to then the task has to execute with a set of rules and regulations. Okay, so it's the meaning of the systems. Okay, so it's meaning for so the embedded system is mentioned for when the to embed both one design or design to another design. Okay, so to merge one platform to another platform, it's meaning for the embedded. Okay, So it's meaning that means then embedded is mentioned for hardware and then to combination of both hardware and then software, then both combinations to run the embedded system. Okay, so the system and then embedded to merge. So the embedded system is mainly to create the design purpose only. So to create the designers and then to create the application oriented functions. For example, to take in your home. Okay, so taking in your home and your real time. Okay, so most of the things is depends on these embedded systems only. Okay, so for example, to take laptop and then phone and then TV, washing machine or anything. Okay, so all things are running into depends on this embedded system, right? My screen is visible.
Yes,
So
sir.
now it's visible, sir, in Zoom.
Okay. So then the most of the things then this embedded system is running into so most hardware and then software and then another the hardware is mentioned for the microprocessor and then microcontrollers. Okay. So anybody know then what is a microcontroller and then what is a microprocessor and then difference between for microprocessor and then microcontroller. What is microprocessor and then what is microcontroller? So in this microcontroller is represent for the microcontrollers, for example, then 8085 microcontroller, and then Intel the processors. So then Motorola process, the Snapdragon. These are all the processors. Okay, so the processing. So it's a difference between the main one. Then to come to take in your real time, then desktop is a processor, and then your mobile phone. Okay, so mobile phone is a then one is a microcontroller. Okay, so why the mobile phone is a microcontroller and then the desktop is a processor means so to create the functional blocks like CPU, ALU, and then memory control units, and then RAM, ROM, then the timers, registers, peripherals. These are all fixed into separate boxes. Okay, so for example, to take the computer desktop. Okay, so the CPU is a separate one, and then RAM, ROM, then the IO functions, then zip peripherals. These are all separate, fixed into separate boxes. Okay, so once to fix it into separate boxes means so the size is very bulk and then the cost is more, and then the
Sir, can you make it a full screen, sir?
sir,
Full screen, full screen.
full screen. Okay. Okay. Okay, so these are the microprocessors. Okay, so to create at the same time to compare the microcontroller. So microcontroller has fixed into the single chip. Okay, so all functional blocks are fixed into the single chip. That chip is IC. Okay, so all are know the ICs, right? In integrating circuit. So for example, to take the once the IC is damaged, then the whole circuit cannot be running. For example, to take mobile phone. Okay, so in this mobile phone we are used the main one is a motherboard. Okay, so in this motherboard, then in this motherboard has fixed into to create the circuits, then all circuit has to link, all circuit has to fix in the one functional IC. Okay, so the ICs is in this ICs are fixed to RAM, ROM, memory, in IO functions, peripherals, timers. These are all built in that particular IC. So in this IC has in this first time, then the IC has to create to then one room big size. Okay, so the size is more high, and then but the processor is very low, and then the memory functions also is very low. But so in this time, then the ICs in this ICs are used into nano chip. Okay, so in this nano chip, but the process is more high. So instead of ICs, we are using into millions of transistors, diodes, and then capacitors we are used. So why using the different multiple transistors and then bulk transistor and then capacitor diodes are used means so the processing speed is more high. Okay, so for example, to once to bought in your mobile phone or anything, buy in your mobile phone or anything. So first to check in your specification, right? So first to check in your specification, then the particular specification is more high means to wants to go to buy. At the same time to check with the RAM and then ROM, right? So RAM, 8 GB RAM or anything, RAM is also more high, right? So these things cannot. So once the processor is more high means then the system also is running into high speed. So it's due to the accuracy and then processing speed is more high. So that purpose only using this processor is more high. Okay, that the same these are the difference between for microprocessor and then microcontroller. So all functional blocks are fixed into single chip. But microprocessor we are built into they are built into separate blocks. Okay. So at the second point we are discussed to in this microprocessor, then the external functions can be added. For example, then the RAM and then ROM. Once the RAM and then ROM has damaged, to replace the anyone at the same time to additionally to external added for the any RAM and then ROM or any function CPU or anything. But in your microcontroller cannot they cannot any functionals. Okay, so it's a fixed one. Once the IC has damaged, then go to move for the another ICs. But then to use the microprocessor, we are once the IC has damaged to replace it, then to use that particular system, particular things. Okay, so these are the second point. Then third one. So in this microprocessor has executed the task at many tasks at the time. For example, to take the newer laptop or desktop. Okay, so these are the processors. Okay, so in this processor we are used to at the same time you are running into multiple tasks. For example, wants to play the songs, then go to search the Google or anything, then at the same time to play the videos. So to write the script or anything at the particular at the time to running into multiple tasks in this microprocessor. But in your microcontroller to execute the single task only. Okay, so in this microcontroller we are using different microcontrollers. Okay, so pick microcontroller. So pick microcontroller, AVR microcontroller, ARM microcontroller, Arduino, Atmeha 328. There are different microcontrollers are used. So in this microprocessor, we are using into general applications only. Okay, so microprocessor is used to general applications, and then microcontrollers are used to designing and then application oriented functions only. Okay, so to it's execute the task at single task at the times only for the microcontroller. But microprocessor is execute the many tasks at the time. So these are the difference between for microprocessor and then microcontroller. Okay, so how embedded system is working. First to collect the input. Then how to collect the input means using the sensors. So for example, to consider in your mobile phone. Okay, so there are using different sensors are used. Why using different sensors? So for example, fingerprint sensor, touch, then gyroscope, navigation, ambient sensor, then proximity sensor. There are using different sensors. Okay, so why in this particular things why using different sensor means then particular sensor has sensing the particular values, but environment parameters. Okay, so for example, fingerprint to read the fingerprint values only. Then the same time wants to click the touch and then then go to enter the another displays. Okay, so at the same time to collect the input value, it means to sense the environmental raw data. So after collecting, so next then go to transmit the processors. Okay, so in between gap, then the sensors and then processors in between gap we are used to ADC converter. So okay, so why using ADC converter means then if to consider any machines. So to consider any machines, all machine is running into binaries only. Okay, so that means zeros and ones only. Okay, so one means high, and then zero means low. So the output is a discrete output. But we are use or know the analog output, digital output, right?
The slide is not moving, sir.
So I just give the intro of the embedded system only. Okay. I'll know the embedded systems, right? So wait few minutes. Okay, so sorry for the disturbance. Then, yeah, tell me. Anybody know then analog output and then digital output? What is analog output? What is digital output? Then analog output is a continuous output. That means then it's collect the infinite data and then output is also as sending to infinite output. Okay, so but the digital output we are considered to discrete signal. That means zeros and ones only. Okay, so the values is high. So I give the particular voltage or to give the data, then the values is 1. So then to give the low voltage, the values is 0. So these are the digital output. So all machine has to running into depends on these binary values, those zeros and ones only. So these are the discrete signal. But sensors to collect the infinite values. Okay, so after to collecting, so to transmit the microcontroller cannot accept it. So microcontroller cannot accept it. Okay, so that means then we are used to collect the data to transmit. Then how to use the ADC converter? So to ADC converter we are used to convert the analog to digital values. Okay, so after converting to transmit the digital value to the microcontroller. Okay, so these are the controlling unit. So instead of controlling unit, these are used to then ALU, CPU, and then memories. Okay, so these functions are used. Why using CPU and then the ALU means then these are the arithmetic operations like addition, subtraction, multiplication, division. Okay, at the same time, the processor is also more high. To then the processor then CPU has to calculating these functions, right? So it's calculate the some of the additions like subtractions, multiplications. So the processor is also more high. Then after then the output is a actuators. Actuators like to control anything like fan or light. Then to control anything. Okay. So in this embedded system has classified into depends on this two types. One is a normal embedded system, another one is a microcontroller based embedded system. Okay, so in this normal embedded system, like normal embedded system is mentioned for application oriented embedded system. Then what are this application oriented embedded system? Embedded system means then like to consider using in your daily lives. Okay, so for daily usage things are TV, then to take consider for in your home. Okay, uh, TV, washing machine, fridge, then microwave oven, then mobile phones. Okay, so digital watches, then DVD, then digital cameras. These are all normal specific embedded system. At the same thing, and the another one point, then the embedded is embedded. What is embedded means then to combination of hardware and then software. It's a main one firmware application. So what is the firmware application means the hardware is a separate one, but software is separate one for the embedded. But then the firmware applications is used to high application domains only. Okay, so why using high application domains means so then the hardware is a more processing and then software is a more complicated. So that for example, then in this embedded we are using normal controllers. Controller is a separate one. After software is a separate one. So in this firmware application, we are considered to instead of hardware, then the software is running. Okay. So once you turn on your hardware, then software is automatically running. Then go to write the program instead of the hardware. Okay. So it's a firmware application. So in this firmware application used for high application domains like banking sector, then aircraft. These types of applications are used. Okay. So it's to give more security and then hardware are more complex and then software is also more complex. Okay, so then how we used the banking settlements like to consider the ATM machine. Okay, so then the structures once the outside is the hardware instead of the fully software is running. Okay, so for example, then go to swipe in your EVM chip, then automatically to read the cards and then to give the details. Okay, so then how it's working to the backend is running into fully softwares. Okay, so the same to we are considered the aircrafts also. Okay, so these are the these are the running into firmware applications. Okay, so in these normal applications we are used into daily lives. Okay, so like the fridge, washing machine or anything. So these are the daily functions. So for example, to consider the washing machine, then washing machine how it's work. So then already to bulk the more contestants. Okay, so only 100 members only to join. So if anybody cannot join means then go to watch the live. Okay, so please share the YouTube link for our colleagues. Okay.
Yeah, yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay, to share the link, YouTube link in your to the colleagues.
Yes, sir. Already shared, sir.
Okay. Yeah. So okay, clear. So then in this embedded system classified into normal application oriented embedded system and then microcontroller based embedded systems, right? Then the microcontroller is mostly used for the companies only. Okay, so like small scale industries or large scale industries or medium scale industries or any industries. Okay, so there are used for the different hardware. For example, there are low level industries are used for then processor, then the controller is used for the low bit operations controller, and then large scale industry is used for the complete more complexity controllers. Okay, So depends on this industries based, and then the application based use the different controllers. Okay, so starting to 8-bit microcontroller to 32-bit microcontrollers. Okay, so you are using to 8-bit microcontroller means then software is very less, and then easy users to easily to interact to. Then the program is more very simple to write. Okay, at the same time you are using the high level industries. Okay, large scale industries that are used to 32-bit microcontroller. So used for the 32-bit microcontroller, then the program then the hardware is running into then the more complexity, and then registers and then the buffers are used to write the program, and then the software is also more complexity. Okay, so that purpose only using for the different stages used for the different microcontrollers. Okay, so in then another one, application based embedded systems like real time embedded system used for, so already I told, right? Then firmware applications, so using ATM machines and then aircraft, then that's these are used for the real time embedded system. Then next one is a standalone embedded system. Standalone embedded system we are considered to we are considered then your digital watches, digital watch, and then DVD or anything. Okay, so digital camera, these are all our embedded system. Then how it's working, standalone embedded system. So to get the signal, okay, so for example, to consider the DVD. Okay, so wants to insert to give the DVD player. Okay, so wants to turn on your DVD player to put the CD. So then how to then how to display the video. So automatically then the CD driver has to rotate continuously to read the signal. Okay, so to read the signal, it's continuously, but then instead of chip has to controller. Okay, so instead of one particular chip has used it, so the chip has to converting into digital. Okay, then the frames also has to sending to digital values. Okay, so then the picture, then the to convert the pictures, and then after already after to merging, so to display the videos. Okay, so these are the functions of the embedded system. Okay, if anybody doubt for the embedded system, so these are the basic. Then next another one is a main concept. Okay, so in this particular classes, so another one is a communication. So in this communication, we are considered to normal WSN communication. There are different types of communications are used. Okay, so different types of communication means then wireless communication or wired communication. Okay, so then the wired communications like as USB cable, then how to connect the data. Okay, so then how to transfer the data from one place to another places using wired or wireless. Using wireless means then the concept is in WSN. Okay, so we are normal. Then in this functions we are then in this communication we are considered to online or offline or anything. Okay, so online communication or offline communication. Offline communication means you are used for the all or not the Bluetooth, right? All or no Bluetooth, right? So we are then all are using Bluetooth headset or Bluetooth speaker or anything. Okay, then how the data has to transferred. So that is a WSN function. Okay, so to pair the devices. So to we are considered one device to another device. Then how the data has transferred. That is a WSN concept. Okay, so if then to read the environment, to read the bulk data. So to for example to read the environmental data like to sensors monitoring, like then the air pollution, the noise pollutions or anything, to read the sensing values to in our environmental to collect the raw data. So the data has to transferred from to receiving from another places. Then how to transfer using offline communication or online communication. Okay, so it's meaning for then in this embedded system we are using different communications are used. One is a UART communication, another one is a serial communication. Okay, so in this UART communication is meaning for universal asynchronous receiver and transmitter. Okay, so it's a bidirectional. In this embedded system we are using to bidirectional communication system. All are know the communication systems, right? Hello, all or no communication. So then how it's working? In this communication, we are used to single direction communication, single direction and then bidirectional. Single direction means then data has transmitting only. If any data cannot be receiving. Okay, so it's a single direction. Okay, so it's meaning for bidirectional, then data has transmitting and then receiving. So it's like as it's in this bidirectional we are used to two types. One is a half duplex, another one is a full duplex. But data has to bidirectional. So half duplex is meaning for, to example, walkie-talkie. Okay, so walkie-talkie is one of the communication. Then how it's working? It's a frequency. It's communicated to one particular frequency ranges. Okay, so it's a bidirectional it acts as trans receiver, but half duplex communication system. Why means it's first transmitter to transmit the data after receiving. So after receiving this particular person transmit another one data. So it cannot sending continuous data. Why means it's to create to transmitter and receiver to sending same data means it can create a collider. Okay, so to data can be merged, so it can be collider. Okay, so if any data cannot be received for both persons, so it's a half duplex communication system, like for example, walkie-talkie. Okay. So next another one is a full duplex communication system. Full duplex communication system like us. So all are using messengers, right? So messenger is one of the WSN system. Okay. Messengers like WhatsApp, Instagram, or anything. Okay. So it's also like us then in your mobile phones also. Okay. So these are also then to chat within your friends or to call in your friends. Okay, so same time you are speaking and then same time you sending this message, send the messages. Okay, clear? So it's data can be transmitting and receiving simultaneously. It can creating any collateral functions. Okay, so easily your data has to transmitting and receiving. So these are the communication systems like a WSN function. Okay, any doubt? If any doubt means to ask me, question me. Okay, so in this embedded systems we are used to, there are different microcontrollers. So in this embedded system we are used to, then in this WSN we are used to different microcontrollers are used. So like then Raspberry Pi, then BeagleBone board, Arduino, then Arduino, Nodon CU, Intel Edison, then Arduino Mega, then ARM7 or anything. So okay, so this is one of the part of the controllers. Okay, so to then WSN to connect any other controller, all controllers has to support it for the WSN concept. Okay. Hello. Yeah, please respond me. Okay, clear. Okay, next then in these classes we are discuss the controller for Arduino microcontroller. Okay, so why I am selecting this Arduino microcontroller means then Arduino is easy to beginners is easy to learn for the embedded system. Okay, so it's then the hardware architecture is very simple, and then it's a open source microcontroller. Okay, so it is a open source microcontroller, so all are used beginners is easy to learn and then easy to identify, then it's a embedded system. Okay, so that purpose only is using this Arduino microcontroller in these classes. At the same time, to easily to communicate for the WSN functions. Okay, so easily your data has to transmitting and then receiving in this WSN concept. Okay, so it's a open source, directly you then go to Google it. So so why the Arduino is a open source microcontroller means, so then the Arduino IDE software is also open source. Okay, so the most of the softwares to pay at the time only license has to give. Okay, so at the time only to we are use that particular software. But in this Arduino IDE, in this open source, directly then go to Google it to download the Arduino software. Okay, so that is a open source electronic board. So in this Arduino, we are using the control. In this Arduino, there are using many types. Okay, so in this Arduino has to at the same time it's supported for the many libraries. Okay, so to connect the cross platform like Arduino to Python, Arduino to MATLAB, Arduino to any other software. Okay, so it is easy to support and easy to support for the many library functions. Okay, so at the same time we are use the language C languages only. Okay, so I hope all are know the C languages. Okay, so it's then the syntax also very simple and then easy to communicate for this particular microcontroller. Directly to write the program, then to dump the program in our to the microcontroller to give to take the values. Okay, So that purpose only using this Arduino in these classes. So now I am using this controller for Arduino UNO. So in this Arduino UNO, it is one of the microcontroller. So in this Arduino there are used for the many types. Okay. Then Arduino Nano, Arduino Mega, Lilypad, Ethernet, Pro, Mini. So there are different types of boards are used. So there are different types of boards are used. So now I am using the board for Arduino UNO. Why I am selecting this Arduino UNO means to connect it to the minimum sensors. Okay. So for example, to take the Nano or Mega means to take the Nano sensors, Nano microcontroller means to connect the few sensors only, to connect 2 or more sensors. But Arduino UNO to connect to the minimum sensors. Okay. So to around depends on this IO pins. Okay. To take any processor or any microcontroller, so to consider the IO functions, all are used for the IO functions. Okay. So in this now we are discussed to briefly then Arduino architectures. Okay. So first we are discussed to the Arduino plug. Then first one is the Arduino USB plug. Okay, so it is used to connect the data transmitting and receiving USB functions at the same time to give the power supply. So it's take the input power supply 5 voltage. Okay, so then why using USB function means then you are use the hardware is a separate one and to write the program in your laptop. So after to write the program to dump it to the microcontroller, so the data has to transmitting through in your laptop USB cable. Okay, so that purpose only using this USB plug in this Arduino. So next one is a power supply to give. So to give input to give the power supply, 2 types of power supply. One is a USB plug, another one is a power supply port. It's considered for the DC power jack. Okay, so to DC power jack, then to give the directly to give the power supply to give the power plug. Okay, so it's accepted the voltage for maximum 12 voltage. So minimum 5 voltage and then 9 voltage adapter or 12 voltage adapter. Okay, so DC power jack. And the next one we are discussed to IO pins. Okay, so in this controller we are used 2 types of IO pins. One is a analog and another one is a digital. Okay, so I hope all are know that digital and then analog, right? So what is digital and then what is analog means then digital pins we are consider the values zeros and ones only, but then analog then to connect the any sensors directly to connect the analog pins. Okay, so to consider the actuators or to give the inputs values like all values are accepted for the zeros and ones only for the digital pins. Okay, so there are in this digital there are 14 digital pins are used. Okay, so 0 to 13. Okay, so these are the digital IO pins, and then there are 6 pins are used for the analog IO pins. Okay, so then directly the sensors directly to connect the IO analog pins. Okay, so then we are used then already I told then the sensors and then processor we are used to in between gap we are used to the ADC functions. Why in this controller we cannot use the means then already inbuilt ADC functions are used in this microcontroller. So directly to connect the sensors in the particular pin to select the particular pins directly to connect to read the sensors values. Okay, so next another one is then at the main thing for the WSN concept serial communication pins. Okay, so in this in this 14 pins we are used for the general purpose input output pins. Okay, for the digital two additional functions 0 pin and then first pin to add the functions for the serial communication. So it's a inbuilt serial communication pin. It acts as 0 pin and then first pin. 0 pin acts as transmitter and then first pin acts as receiver. Sorry, 0 pin acts as receiver and then first pin acts as transmitter. Okay, so if any data has to transmitting to connect the pin number, transmitter to connect the pin number 1. So if any data has to receiving for the microcontroller to connect the pin number 0. Okay, so it's to connect the opposite connection. So transmitter and then to take the transmitter and receiver to connect the opposite function, transmitter to receiver, receiver to transmitter. Okay, so next we are discussed to IC. Okay, so it's IC, all function has to built in that particular IC. So if any so in this IC has to fixed for to consider the power supply ports and then IO functions for digital and then analog. Okay, so there are used for in this ICs was in this IC's name was Atmeha 328 IC. Okay, so there are 28 pins IC, right side 14 and then left side 14 pins. In this 28 pins we are considered for analog pins and then digital pins and then power supply ports. Next another one is a crystal oscillator. Okay, so this is a crystal oscillator. Crystal oscillator is used to connect to maintain the frequency. Okay, so that means then to maintain the CPU range. Okay, so that purpose only using this crystal oscillator in the microcontroller. So next one is the regulators. So in this regulators there are used for 5 voltage regulator, and another one is a 3.3 voltage regulator. So why using this regulator means to drop the voltage. Okay. So in this microcontroller we are accepted to send the output voltage 5 voltage only, but to give the input voltage accepted for 9 voltage to 12 voltage maximum, minimum 5 voltage, maximum 12 voltage. Okay. So but then Arduino has Arduino has to send the output voltage 5 voltage only, so to drop the voltage, so using this regulator. Okay, so there are used two types of regulator. One is this is a 5 voltage regulator, and another one is a 3.3 voltage regulator. Okay, so after converting to send the output voltage for 5 voltage output pins, and then 3.3 voltage output power supply pins. Okay, clear. Then next another one is a reset button. So reset button is used to, if any controller cannot be properly working, wants to click the reset button, the program has to starting. Okay, so that purpose only using this reset button. So next we are discussed to then how to start the Arduino. Okay, so directly then go to Google it. So then this Arduino IDE software is available. Okay, it is a open source. So after installing, okay, so it's a specification operating voltage, it's 5 voltage, and then to give the input voltage 5 voltage or minimum, maximum 12 voltage. So next digital pins. In this 14 pins we are used there are using 14 pins. In this 14 pins we are used to 2 pins is a serial communication, another 6 pins used for PWM function. Okay, so what is PWM? PWM is used to control the pulse, pulse train. Okay, so pulse with modulation. For example, it's mainly used in these functions is mainly used uh, to drop the voltage for the to drop the voltage train. Okay, so for example, to control the light intensity, to control the motor speed, and then fan speed. So that purpose only using this PWM function in this Arduino microcontroller. Okay, so next analog pins, analog input pins are 6 pins, and then DC power pins, IO pins for to take the 40 milliampere, then to give the DC current for 3.3 30 milliampere, and then used for the memory. Okay, so to 32 KB at 328 IC. Okay, so it acts as bootloader. So next one is a SRAM, and another one is a EEPROM RAM. So clock speed is a 16 megahertz for it's maintained the crystal oscillator. Okay, so these are the ICs. So there are 28 pins IC. In this 28 pins IC has to connecting for the pins. Okay, so digital IO pins, analog IO pins, and then crystal functions. Then next one is a power supply pins. Okay, so all function has to fix into that particular IC. Once the IC has damaged, then whole circuit cannot be running. So to at the time to go to change the another microcontroller. Okay, I hope all are clear, right? So these are the basics. Okay, so these are the basics of microcontroller and then specifications. So if any doubt means to ask me and then question me, or otherwise shall I go to the program? Hello, please respond me, or otherwise to chat on the chat box. Okay, so next then go to then how to start the Arduino IDE. Okay, so in this first to install the Arduino IDE software. So after installing, it's a default function. In this Arduino IDE has to default function. In this program structures used for the default function. One is a setup and another one is a loop. Okay, so first in this, then once to go to after installing, then go to select the Arduino IDE software. So once to click the open the Arduino IDE. So in this Arduino IDE software as using for the two program structures, it's a default function. One is a void setup and another one is a void loop. Okay. So it's briefly discussed. Then first one is a menu bar. So in this Arduino IDE is used for the one is a cross-platform, and then same thing we are using the language for C program. Okay. So I hope all are know the C language. Okay. So directly then go to write the program. So in this case, so we are used for the embedded C, not for pure C language. So we are used in C language to merge the embedded. Okay. So it's a embedded C. Okay. So first one is a menu bar. So menu in this so this is the main page of Arduino IDE working space. So to first one is a menu bar. So menu bar is used to create the sketches, then the help functions to create the new library, to add the library. So then the editing functions, so to create the new files. So these types of these types of menu options has available in this particular menu bar. Okay, so there are file, edit, sketch tools, and then helps. So next one is a button bar. So in this button bar, we are used to 6 types of button bars are used. So 6 types of button bars used for the different functions. So one is a first one right side. So in this left side, we are using to 5 button, and another one is right side used for the 1 button. Okay. So in the first one is used to compile the program. The tick mark, right? So it is used to compile the program. So after to write the program, then go to compile the program. So in this functions you use it to if the program is right or wrong to check the compilation error. Okay, so if any error, then the error message has to sending to display the notification area status bar. Okay, so first one is there to compile the checking error. So next one is used to upload the program. After then the program is done compiling, then go to upload the program to the microcontroller. So use the second button. Okay, so next button third button is used to create the new sketches. So next to fourth button is used to create the so directly to open the example program. So fifth button we are used to save the sketch. Okay, so to save the particular file. So next in this right side we are used to another one button bar. Okay, so it's a serial communication. So that means serial monitor. So in the serial monitor is mainly used to, it is one of the communication function. Okay, so easily your data has to transmitting and receiving in serial functions. Okay, to the board and then software. Then how the data has to transmitting and receiving through USB cable. Okay, so after done uploading, if any data has to print, if any sensor value has to display in any other displays, any other external displays, or otherwise using serial monitor. Okay, so that purpose only using this serial communication. Okay, so these are the button bars. Next, another one is the input and edit area to write the whole program. So next one is a status bar. Status bar is used to indicate the status messages. Okay, so there are 3 types of messages has been stat, uh, 3 types of status message has to sending. So one is a done compiling, uploading, work loading status, and another one is a wrong serial board connection, wrong serial port connection. Okay, so these are the 3 types of messages to sending. So these are the status message functions. So one is a working upload worked. So once the done compiling or done uploading, so the message has to send. Okay, so at the same time, another one is a wrong serial port connection, wrong board connection. Okay, so how to select the wrong serial port and then serial board. Okay, so in this Arduino already I told. So in this Arduino there are different types of boards are used. Okay, so then first to go to tools, then go to select the board. Okay, so there are different types of boards are used: Arduino Nano, Ethernet, Beat, Bluetooth, Mini, Pro, Nano, robot controller. There are different types of boards are used. Then to select the particular board. So why means, so most of the pins to take the Arduino Mega, there are used many IO pins. Okay, so to write that particular pin, but to select the Arduino Uno controller means then the pin has to not accepted. So it's sending to error. Okay, so it's sending to error in status messages. So next another one is a serial port. So in the serial, then the same thing. Then go to click the tools, then the port to select anyone. Okay, so depends on this to wants to plug the Arduino microcontroller in our laptop. So then the particular port has to visible. Okay, so it's meaning for then to mention the USB. Okay, so to select the serial port, then your data has to transmitting and receiving depends on this port communication. Okay, clear. So next then go to the program. So in this program, Arduino is a Arduino program is a case sensitive. Okay, so why the program is case sensitive means to using this many keywords. Okay, so then the program has to writing into different keywords and then different structures. Okay, so you cannot using any keywords means the program is sending into error, sending different errors. Okay, so next another one is a next point is a then after to write the after to ending the ending this particular line to put on the semicolon. Okay, so I means we are use the C languages. Okay, so it's a default function. So next to give the command line means to give the double backslash or otherwise to put to give one particular paragraph means to put to give the functions backslash star and then starting and then ending use the star and then backslash. Okay, clear. So next to go for the program structure, it's a default one is a void setup and another one is a while loop. So void setup is used to setting function. Okay, so it's used to for the to set the variables and then pin modes, libraries, and then example files. So this to declare the data types. So these functions are used to instead of void setup. Okay, so in this void setup has running into single times once to start the program, then void setup has to running into single time only. Okay, so but then the void loop to write the main program in this embedded system is continuously running. If any time to start, then the embedded system is continuously running. Okay, so first then to write the main program instead of void loop scope. Okay, so it's continuously it's a infinite loop. So wait few minutes. Okay, so it's clear for the programming structure. One is a void setup and another one is a void loop. Void setup is used to set the libraries and then to set the pins and then to set the different modes. Okay, so to set the libraries and then data structures. So these functions already setting into instead of void set loop scope. Okay, so next to void loop, it's a infinite loop. Okay, so to write the program main program instead of void loop scope. Okay, so next go for the program. Then in this first program we are discussed to then how to turn on. So it's a functions. Okay, then how to write the program. So that means IO pins, using this IO pins for digital or analog. So using this functions. Okay, so use the four in this Arduino has to write the program fully depends on this four set of modes, four set of functions. So one is a pin mode. Okay, so pin modes used to set the pin number and then mode. Okay, so in this pin mode has setting into instead of void setup. First to declare the pin number for digital pin or analog pin. Okay, so to select the pin, then the mode has using to input mode or output mode depends on the sensor. Okay, so then how to then using this first to set the pin mode to select the digital pin to set the mode, then how to write the void loop. Okay, so then which functions are selected. So first then to set the pin mode to set the digital pin to set the digital pin to select any other pins. Okay, so to select 0 to 13, so use to 40 to select any one pin to set the mode. Okay, so to set the mode for first digital output. Okay, digital pin, the mode is output. The mode is output means we are used the function digital write. Okay, so digital write means to write the condition. For example, the particular time to write the condition, turn on the LED or turn off LED or turn on fan or anything to write the actuators or anything. Okay, so to write the function digital write to set the pin number and then to give the value. Okay, so use the same pin number to give the value high or low. So at the same time high or low, and then next another one same time use the pin mode. Use the pin is a digital pin, the mode is input. The mode is input means so it's the values are high and low only. Okay, so that means the zeros and low. Okay, so to use the condition digital read to read the pin number, the particular pin. Sensors is to read the sensors value, sensing raw data. After sensing this raw data to transmit the microcontroller, then the values also zeros and ones only. Okay, so for the digital. So use the digital pin, the values is 0 in the pin mode to read directly to read the pin number to use the condition digital read. At the same time to use the analog function, analog read. Use the pin mode, the pin is a analog pin, the mode is output. So it's a default mode for the analog. Okay, So why means it cannot, it's a infinite, it's sending the output is a infinite data. Okay, so it's a continuous function. So it uses the pin number is a default input state only. Okay, so it's used for the analog pin. The mode is input. So use the function analog pin to read the pin number. Okay, so these are the basic structures of basic program structure. So next one is the Arduino timing. So Arduino timing is used to pass the to pass the program for the particular seconds or milliseconds. Okay, then how to pass the delay seconds means use the two types of condition. One is a delay and another one is a delay microseconds. So delay microseconds, there are three types of condition we have to pass it. So one is a milliseconds and another one is a seconds and another one is a microseconds. Okay, so for example, delay microseconds to enter the value, to give the value for 1 minute, then time has to it's Arduino has to take the pausing time 1 microseconds. Okay, so use the same condition delay microseconds to enter the value 1000. To enter the value 1000 means Arduino has to take the value for to pass the program 1 milliseconds. Okay, so 1000 microseconds equal to 1 milliseconds. At the same time, so delay to enter the value 1 means in this condition Arduino has to take the to pass the program for 1 seconds only. Okay, so at the use of the delay functions to enter the value 1000. To enter the 1000 means it's in this time Arduino has to take the value for 1 seconds. Okay, so delay 1000 it's meaning for 1 second. Okay, so 1 millisecond, it's clear. 1 microseconds equal to 1 microsecond. 1000 microseconds equal to 1 milliseconds. Okay, so 1000 milliseconds equal to 1 second. So this is the Arduino timing to pass the program. So next one is a digital and analog. So digital, there are two values only. One is a on and off. The high and low, so all are same, 1 and 0. Okay. So next analog, analog has a many infinite values. So how to convert to the ADC converter? Okay. So the how to convert the analog to digital value. So this is the working principle. First to give the analog input for the ADC converter. So to apply the low pass filter and then sampling and quantization function to convert to the values analog to digital after to send the binary output for zeros and ones. Okay, so all to get the digital binary values. Okay, so computers do not relate to analog, they are quantizing. So after they are using this analog 6 pins. Okay, so in this first program we are discussed to then how to start the Arduino. Okay, then how to set the pin number, then how to select the pin number, then how to use, then how to so in this WSN concept we are used the to collect the data in parameters. Okay, so to collect the using the hub or anything. So in our environment, for example, to take the home, to collect the all data, then how we transferring. So first to set the pin number to read the using the sensors to read the values. Okay, so after WSN is one of the concept to transmit the data from one place to another places. Okay, so first we are discussed then how to start the Arduino. So first we are discussed to LED blinking, then how to set the pin mode, then how to use the conditions. Okay, so first we are discuss the LED blinking. So first to set the pin mode to select the pin, the mode is output. So in this mode depends on this sensors. Okay, so actuators fully is running into output. So all sensors is using for the mode is input. Okay, so actuators like then fan, LED light. So these types of conditions all are running into actuators to write the condition to a particular time to LED has turn on. Wants to write the condition LED off. It's possible for this pins. Okay, so it's to give the value 1 and 0. Okay, so for use the mode for output, and another one is a digital, right? Use the pin. So to use the pin mode, pin is a digital pin, the mode is output. Okay, so which conditions are used to apply the digital, right? Use the pin number to give the condition. So which condition has to pause it? So particular time then to write the condition. In this time the LED has high, in this time LED has to low to pass the command. Okay, so it's like automation continuously wants to start the program. Automatically LED turn on and then turn off due to depends on this delay seconds. Why using delay seconds? So in this program, to wants to start the Arduino controller, Arduino has to running into executor to within fraction of seconds. Then the state cannot be visible for humans. Okay, but controller has to execute on state and then off state. But the state cannot be visible. Once the state can be visible for on state and then off state means, so use the delay seconds. So then in this program as executed into line by line. First executed first line, after the executed second line, delay 1000. Delay 1000 is mentioned for to pause it there. Then the program is pausing into 1 second. Okay. So 1 second means LED high in 1 second. After 1 second, LED low. Okay, it's continuously. It's an infinite loop. Okay. So after ending this line, then go to start with the first digital right and then ending. Okay, so it's continuously running. Then how to connect the sensor, then how to connect the sensor, it's the connection of the to connect the LED. Okay, so to select the pin number in this LED has two end, one is a anode and another one is a cathode. Okay, so anode is positive and cathode is negative. So anode, then how to select the then how to get anode part and then how to select the cathode means, so to consider the LED. Okay, so the high lead right, then the lead is more high, so it's a cathode, and low lead is used for the anode. Okay, so it's a positive supply directly to give the positive supply and then directly to give the ground. So then now we are selected the 13th pin, so to give the power supply, then how to pass the power supply means already I told Arduino has to give the output voltage 5 voltage for the each pins. Okay, so each pins are accepted for the input set and then output set. So for example, to take the any pins, second pin or third pin, fourth pin or 13th pin or anyone. Okay, so all pin has to accepted for the input mode and then output mode. Okay, so now we are using the mode for output only to pass the voltage. High means to pass the 5 voltage for that particular pin. Low means to pass the low voltage. That means 0 voltage. Okay, so to pass the 5 voltage means LED turn on. 0 volt means LED turn off. Okay, so once I show the output in simulation, so to follow order to follow the then how to show the output, then how to display in your output means, so using real-time hardware. Otherwise I show the output in demo in simulation software. One is a Proteus and another one is a Tinkercad in online or Proteus is offline. Okay, so directly go to sign up in your account in Tinkercad. So it's a one of the online simulation software, and another one is a Proteus. Proteus is offline software. So I show the output in Proteus. So first to open the Proteus, then go to click the new project, then go to create in your own project. So to select new project, then next to enter the project name, project detail, and then to add the path. Okay, so to select any path to the file path saving location, then go to browse it, or otherwise using same path. Then go to after to fill the name and then path, select the name and then path, then go to click next. After finish, then the working page has to created. So this is the PCB design to create the one circuit. Okay, so it's a working platform. Then how to select, then how to use the Proteus, then how to select the component, then how to select, then how to connect the circuit. Okay, so it's a simple for this Arduino controller. So use the same circuit. Okay, so first to select the Arduino controller, the next to select the LED. Okay, so in this anode and directly to connect the positive and cathode and directly to connect the negative. Okay, so first to write the program pin M using caps. Okay, so it's a case sensitive, we cannot using M caps means, so the program cannot then the particular command cannot be change cannot be. So using pin M using caps. Okay, pin mode. So now to enter the pin number. Okay, so to enter the pin number, to select any pin number, now I am selecting the 6th pin. So to enter the mode output. Okay, so next then go to write the condition digital write. Okay, so digital write. So now to turn on the LED. Okay, so use the condition sixth pin, comma, high. Enter few delay seconds. To pause to few delay seconds, 1000 or 2000, 3000 or anything. So 1000 means 1 seconds. Okay, digital, right? So use the sixth pin, low, delay 1000. Okay, so after then to compile the program, first one, next to save the file. So after done compiling, then go to the Proteus. Then now to create the circuit. Okay. So first, then in this left side there are different button bars is available. Then different button bars used for the different functions. So first to select the component mode. First to select the component. So second one to select the component. Next go to select the device. Okay. So to click the pick device to enter the Arduino. Arduino. So in this Arduino boards is available to select any one Arduino board. Arduino. Okay, so now we are used to Lillipad Mega Nano UNO SMD. Okay, so we are used the board for Arduino UNO. So after to enter, then go to click it. Okay. So next, then go to select LED. Next, go to select LED. So in this LED, there are different LEDs are used. Then in this, then how to select the library? The correct LED means then use the library active library. Okay. So in this library is a LED colors, and then different colors are used. Animation LED. So the library is the active library. Okay. So it's only as working accurately. Okay. So to select any color, blue, green, red, or yellow, or anything, then go to select. Then one is a positive end and another one is a negative end. Okay, so one is a anode and another one is a cathode. So anode and directly to connect to the pin number. So next, directly to connect to the ground. Then how to use the ground means directly to select the, then direct to connect to the ground for the Arduino. Okay, so otherwise to give the external power supply. So in this external power supply is also available. Then to click the terminal, so the ground. Okay, to give the ground. Then how to merge the Arduino software and then Proteus software means to create the hex file. Okay, so in this Arduino has running into .ino file, and then but Proteus has running into .hex files only. Okay, then how to create, then how to convert INO file to hex file means in this options also available. Arduino platform has in this options also available. First to go to click the file, then go to click the preference. Okay, then go to click the preference to put the tick mark for automatic compilation and then upload. After to put the tick mark of all, then go to OK. To then go to compile. After then go to compile. So after done compiling, then go to check the hex file to drag the slide to drag the file. So the hex file is available in the program file path location. Okay, so the program file hex file path location. C users del and then app data, then led.ino.hex. Okay, so to copy that file, then go to add the program. Okay, so to click to edit the component. Then how to edit the component means to click the Arduino, double click the Arduino microcontroller to add the program path. Okay, so otherwise directly to edit the component, then go to the file. So the particular files is available led.ino. Okay, so then okay, then after then go to okay, then go to run the simulation. Okay, then how to start the simulation means there are 4 buttons is available. Then bottom of this page, so in this right side, left side bottom of this page, one is a play button, the next one is a advance the simulation, next one is a pause the simulation, fourth one is a stop the simulation. Okay, then first to start the simulation. Okay, this is the output. Okay, 1 second LED turn on, after 1 second LED turn off. Okay, any doubt? Anybody? If any doubt means ask me. Okay, so next we are discuss serial communication. Okay, so it's a basic program to start the Arduino. Okay, so same thing to read the sensors or anything. So to use the same pin number, use to select any pin number, then wants to read this digital values. Okay, so use the mode is input means directly to write the condition digital read to use the pin number, then the data is stored into one temporary way to create the temporary variable. Okay, so these are the basic functions and the basic structure of Arduino IDE. So next we are discuss the serial communication. Okay, so WSN. So how to write the program? So in this WSN we are used to different modules are used and the different concepts. One is a IoT or anything. Okay, so normal offline communication means we are using the modules for uh, Bluetooth, Zigbee, LoRa, or anything. Okay, so LoRaWAN or anything. So but using online communication means it is IoT. Okay, so if any data has to transmitting through internet. So but in this concept we are used WSN concept is depends on both offline and then online. Today we are discussed to offline communication used for HC05 Bluetooth wireless communication. Okay, then how to data has to transfer from one place to another place, then how to communicate. Okay, so use then how to read the sensors value, then how to transmit the data, then how to the data has to receiving for the receiver end. Okay, the first we are discussed to UART communication. Okay, so in this UART communication we are, so first what is communication already I told, right? If any, the data exchanging from one place to another place, so it's meaning it's a communication meaning. Okay, so if any, one data transfer from exchange from one device to another device. So next in this embedded system running into depend in this communication structure as running into depends on these protocols only. Okay, so what is for not for this communication online or offline any communication using protocols, there are different protocols are used. Okay, so for like to take the internet. Okay, so there are different protocols are used. One is a HTTP protocol, or daily then go to Google it, right? So then the use of the HTTP functions are used. So why using this HTTP protocol? So to access the address, it's that particular protocol to access the particular address only. So it's to create the set of rules and regulation. Okay, so the protocol is meaning for to create the set of rules and regulation. So to combine communication protocol. Communication protocol means to exchange the data from one place to another place. The data has to exchanging depends on these rules and that means set of rules and regulation. Okay, so transferring. So if we cannot using any rules and regulation means if any data has to transmitting and receiving for any persons. Okay, so to sending and receiving for accurately for end to end means using protocols. Okay, so there are different protocols and different structures are used. So first we are used to discussed for offline communication, then UART communication. Okay, so UART means universal asynchronous receiver and transmitter. So receiver and transmitter is mentioned for, so to transmit all data. So to transmit the data from one place to another places. Okay, so in this right side we are using the serial monitor. Serial monitor is one of the UART communication. Okay, then how to data is to transmitting and receiving using USB cable. Okay, hello. Okay, so how to transmit, then for example, then how to read the sensors value, then how to transmit the data, then how to write the condition. So it's the same thing. So it's, I hope all are clear the basics, right? So first, then first to set the, then in the serial communication, if every serial communication, then data transmitting and receiving depends on this one particular data transmission speed. Okay, so for example, to take the pen drive and in your laptop. So it is one device, and then a laptop is another one device. Okay, so if a data transfer from laptop to pen drive or pen drive to laptop, so the one transaction data transaction speed has to visible, right, in this green color symbol. Then how the data has to data has to display data speed in this USB cable. If any data cannot be constant, okay, so the data speed has considered for depends on this USB cable. Okay, so data transferring speed is one second is high peak, and another same time, then next time then the data is low. Okay, so it's a varying. But in this communication we are used to, in this communication system, data has to transfer from one constantly depends on this one particular speed. Okay, so the particular speed is mentioned for to declare the baud rate. Okay, so then how to set the baud rate means there are different baud rate levels are used in this embedded WSN. Okay, so then how the data has to transfer. So it depends on this baud rate. Okay, so then how to set the condition means using serial dot behind. There are using different functions are used. One is a serial dot behind to set any functions for the serial or any. So first, then the setting functions fully set with instead of void setup. Okay. So serial dot behind. Serial dot behind is used to set the baud rate. Okay. 9600. Then how to select the baud rate means depends on this data transmission speed. So few WSN sensors used to high level baud rate, and then few WSN sensors used for the low level baud rate, depends on the sensor. But 9600 is accepted for the all WSN modules like Bluetooth or Zigbee, LoRa or anything, or IoTs concepts also. So okay, so to push the data from one device to another device, one place to another device. Okay, so it's a data transmission speed. The data transmitting and receiving depends on this 9600 bit per second. Data transmitting and receiving 9600 bit per second. Okay. So once, for example, serial dot begin 9600 to print any values. Okay. So now I am print the value for use the condition to print value. Use the condition serial dot print. Okay. So serial dot print to print the value for hello only. Okay, so to enter the delay, to enter few milliseconds, 700 milliseconds, then go to compile, so now I did not using any other controllers. Okay, so we are using controllers means the output has to declare in, and then the output has been displayed in serial monitor. So I did not using any other microcontroller, so the output has displayed in simulation. Okay, so once to stop the simulation, then how to select the serial monitor. Okay, so the particular options also available. So in this right side, then the instrument is available. Okay, so instruments, so oscilloscope, then logic analyzer. Oscilloscope means to plot the graph. Okay, so virtual terminal means to enter the values. So to select the virtual terminal, it's a transmitter and then receiver. It acts as transceiver. Okay. So first, then my controller acts as transmitter, serial monitor acts as receiver. Okay. So to connect the opposite connection. So to connect the same connection means data cannot be transmitting, data cannot be receiving. Okay. So controller acts as, after to dump the program in our controller, data has to transmitting. Use the condition serial dot print hello. Okay, so the hello word, the hello string has to printing in serial monitor. So controller act as transmitter, RX, then in this serial monitor act as receiver. Okay, so to add the program file, then go to run the simulation. Okay, so the word has to print, then the string has printing in serial monitor, right? So it's continuously printing in column wise, sorry, row wise. Okay, so after end of the functions, then go to the next line means use the condition hello, sorry, ln is meaning for new line, print a new line. Okay, so serial is mentioned for to access the serial monitor. So print is mentioned for to print the word or string characters or integer special characters or anything. So ln is mentioned for, then go to the new line. Okay, so after to compile, to add the program file, then go to run the simulation. Hello. Okay, so now it's to printing in line by line. Okay, so after end of the function, then go to enter the new line, then go to enter the next line, printing next line. Okay, so it's a transmitting. Okay, then how to write the receiving? So it's already I told it. Then how to select the serial communication? So it's not, so in the serial communication it's a inbuilt transmitter and receiver. So otherwise to select any other pins. Okay, so then how to select it for the second pin, third pin, 4, 5, 6 or any other pin means to select the, to create the own serial communication for our pins. Okay, so for example, first to enter the library as include software serial.h. Okay, so it's mean for, so to create the own software, it's to mean for to create the own library serial communication for our. Okay, so to enter the pin number software serial, to enter the one, to enter the name. Okay, so to give the name for any name. Okay, so it's my serial, so it's an inbuilt, it's not an inbuilt serial, it's my serial to give any names. Okay, so to I enter the name for tx to select any one pins. Okay, so now I am selected the pin for 7 and 8. So seventh pin act as receiver, so seventh pin act as receiver for the controller, and then eighth pin act as transmitter for the controller. Okay, seventh pin act as receiver and then eighth pin act as transmitter. So now to entered, so we are using the pin number for tx dot behind. Okay, so tx dot behind, sorry, then the word has to printing in serial monitor at the same time to printing in my serial also, serial dot behind, same using this baud rate 9600. Okay, so then now the print has to, word has to printing in tx dot my serial tx dot print. So now to enter bar welcome. Okay, then go to compile the program, then go to now to create two serial communications. One is a, so now to create two communication, one is a inbuilt serial communication, the another one is a my serial communication. Okay, so to enter both, to print the value. So after done compiling, then go to add the library. Same thing to select the virtual terminal for another pin number. Here used the pin number for seventh pin act as receiver, eighth pin act as transmitter. So eighth pin act as transmitter to enter transmitter to receiver. Okay, so it's my serial to enter to give any name, my serial. Okay, it's to give built inbuilt. Okay, then go to run the simulation. Okay, so inbuilt serial has to printing the word for hello, otherwise to selected the my serial for welcome. Okay, so it's the one of the communication. So to select any one pins. Okay, so but to create the one my serial communication. Okay, so to for the 2 to 13 pin. Okay, so next then how to read the values? It's a transmitter. So then how to controller act as receiver, if any other to transmit the value, controller to read the particular data means, then how to write the condition. Okay, then how to read the pin number? So it's same, to enter the value for, first to check this condition while serial monitor is available. Okay, so serial serial monitor is available, to use the condition available serial available. So once the serial monitor is available means, then go to enter the while loop. So while loop is a condition loop. Okay, so while loop is a continuous loop. So if the while cannot true means the loop cannot enter. So while true means then loop go to enter the go to enter the while loop. So then enter the while loop, then go to read the serial monitor. Okay, so to read any characters or any strings or anyone. Okay, so now we enter the character to declare the data type character, uh, to declare the variable or CV or anything. Serial dot read. So use the function serial dot read, or otherwise to read the digital values means to use the condition digital read. Okay, so serial dot read to read the serial monitor, then go to print the value serial dot print ln. So receiving value, so serial dot print ln RCB. Okay, then go to compile. After save, then go to compile the program. So it's clear. Then first to check this condition, while serial monitor is available, so while true, so this condition is true, then go to enter the loop, otherwise then loop cannot be entered. Okay, then go to add the program file. Enter, then go to run the simulation. So now the serial monitor to print cannot print any values. Why means then to enter the values. Okay, so first to set the cursor. Now I am enter the value for you what example, sorry, you only. So it's wait one thing. So to connect to the circuit. Okay, so transmitter, serial monitor act as transmitter, controller act as receiver. So after receiving this value, the data has to transmit to print the value in same serial monitor. Okay, so then go to run the simulation. Now to set the cursor. So now I am enter the value for a, now enter the character a. So wait few minutes. Okay, then go to run the simulation. To enter the character a or any integers. Okay, any special characters or anything. Okay, to print all values k, l, s, d, sc, po, any characters. Okay, so to print the length string, so now I am enter the characters only, so use the condition. So to receive the characters values only. Okay, so use the condition to print the length string or to read the uh, many strings. Okay, so to read the particular string means use the character, use the data type string. Okay, strng string. At the same thing to read to change the conditions also, serial dot read string. Okay, so after then go to compile, then go to add the program file, then go to run the simulation. To set the cursor to enter the word for hello. Okay, welcome all. Clear. So to read the length string, length characters. Okay, so many characters to mention for string. Okay, Then next to print you what example, program. Okay, so it's one of the it's the main program for to transmitting and receiving all. Okay, so it's a receiver program. It's act as trans receivers also. Okay, so in this program we are act as trans receiver. Then how to read then how to data has to transmitting and receiving means same thing. So to print the value. Okay, so same use serial monitor to print the value for print, sorry, serial dot print serial dot println to print the character a. Okay, then to use the few delay seconds to enter delay 500 milliseconds. Then go to compile the program. So now enter the both values. One is a transmitter and another one is a receiver. Okay, so it's continuously act as trans receiver. Then go to add the program file. Then go to run the simulation. It's continuously to print the VA. Okay, so it's a transmitter to set the cursor to print any values. Okay, welcome. So then the it's where cursor has to wait. Welcome. So next to entered query. So okay, it acts as trans receiver. So next, then it's a wired communication. Okay, so how to create the WSN concept means using the same program to create two files. Use the Bluetooth. Okay, so Bluetooth module is also available. Then HC05, HC05 and then HC06. There are two types of modules are used. So both modules also running used for the WSN functions. Okay, so transmitter and there are in this HC05 they are using into two pins. So there are used for four pins. One is a VCC and another one is a ground pin. Next one is a transmitter and then receiver. Okay, so now to enter the two controller. One is a transmitter and another one is a receiver. So first one act as transmitter TX. Next one act as RX. Okay. So to enter the next to select the Bluetooth module. Bluetooth. Okay, HC05 or selected HC06. Okay, anything. Now I am selecting HC05. Okay, so now we are used for the two Bluetooth. One is a transmitter and another one is a receiver Bluetooth. Okay, so the transmitter file directly to connect, receiver directly to connect transmitter pin, receiver pin directly to connect transmitter. Same thing. So the data transmitting to that Bluetooth acts as receiver. Okay, so the Bluetooth transmitting to connected the receiver. After receiving this data, the data has to printed in serial monitor. So use the virtual terminal for the receiver end. So the data transmitting to connected the receiver. Okay, clear. So to create the two program, one is a transmitter and another one is a receiver program. To create new file. So one is a transmitter and another one is a receiver program. So use the same condition serial dot begin 9600. So now I am enter the value serial dot println. So to enter the delay seconds, few delay seconds, 1000. Okay, sorry, 100. Okay, so now transmitting to create the transmitter program. So next we are discussed. Okay, so now we are to write the receiver program. Okay, clear. One act as transmitter and another one program to write the program for receiver program. Serial dot available, serial dot read characters only. So use the characters to change the data type. Character receive equal to serial dot read the receiver value. Serial dot print RCB. Then use the delay functions 100. Then go to compile first to save the file RX. So next to compile the program. So after done compiling, then the transmitter program file directly to add the okay Bluetooth. Transmitter to receiver and then receiver to transmitter. Okay, so the same thing. Then now it's act as transmitter. It's act as transmitter. It's act as receiver. Okay, so Bluetooth same. One is a transmitter and another one is a receiver. So in this time, then the Bluetooth act as transmitter, controller act as receiver. So after receiving this value, the value has to print in serial monitor. So to add the serial virtual terminal. Okay, so add that transmitter and then receiver. Okay, so then go to add the program file. Okay, at the same time, then to add the receiver program file. For that, another controller hex file and then C. Okay, so to add the program file path for that receiver. Okay, so after successfully added the transmitter file and then receiver program. So next, then how to the data has to transfer to connect to pair the device. Okay, so then how to pair the device means. So for example, to taking in your Bluetooth headset or Bluetooth speaker in your mobile phone. Then how the data has to transfer. Then in your Bluetooth music. So first to pair the device using this name or anything. Okay, so the same thing. So first to pair the device. So in this Proteus simulation, you are using in real time means so the name is available. Okay, so Bluetooth HC05 or anything, the particular name is available directly to connect the mobile phone or anything to pair the Bluetooth module. Okay, so but in the simulation to virtually to add the Bluetooth. So one is a first Bluetooth, another one is a second Bluetooth to create the communication. Okay, so manually to add the communication. So how to add the communication means the particular software is also available. So virtual serial port driver. Okay, so then go to add the virtual serial port driver. Okay, so then already then on second then 3 and 4. Now then the port is also available 3 and 4 or otherwise to select any other ports. So now I am delete all ports, all serial communication. So to add the first port is a communication 1 and second port is a communication 2. To add the communications. Okay, so one, two, another one. So communication 1 to communication 2. Then after added paired, then go to set the Proteus. Okay, so to click the Bluetooth, then the physical port is also available to add. First one is a communication 1, So to set the virtual baud rate, we are using the baud rate for 9600, and then the data bus is 8, and then version is also 1.0. Okay. So next go to select another one to add the communication port. Already the port is also 2, and then the baud rate is also same, and then physical data, physical parity is also already set. Then go to OK. Then go to save the file. So next go to run the simulation. Okay, so the data has to receiving, right? So it is a WSN concept. Okay, so to you are using any sensor like gas sensor. Then in the WSN concept, is applications we are implemented into any domains like home automation, environmental monitoring, or van school or anything home. Then industries or anything. Okay, so gas monitoring. So it is one of the concept to create. So then the WSN concept is mainly used to share the data without wireless. Okay, sorry, with wireless. So easily your data has to transfer from one place to another places. Okay, so it's main thing. So easily your data has to transmitting within fraction of seconds. Okay, so in this WSN concept to implement it to controlling and then monitoring from any other places. So it's any for example using online offline communication means, so the Bluetooth is used for the few used for in few ranges only, the particular few meters. But then go to the IoT concept, we are implemented into to monitoring and controlling for any places, like to take the in your messengers. So you are in one places, but your friends in another one places. But then distance for kilometers range or any places. Then one international to another international easily to configure for the IoT. Easily to consider for the easily your message has to transfer from any places. Okay. So that it's easily to implement it, and then any restriction for the WSN functions. Okay. So easily to implement for any things and then any places and then any times. Okay. So it is one of the best communication system to create an WSN concept. Okay, clear? Anybody? So tomorrow we will discuss then online communication through IoT. Okay. So in these classes, if any doubt means ask me. I hope all of you clear, right?
Yeah, yes, sir.
Okay. So if any queries means ask me.
So is there any section, sir?
Sir,
Sir,
not clear.
attendance link is there, sir?
Sir, wait, stay online. I will come. Wait, sir. Stay online. Okay. Then attendance link will be provided on tomorrow. Okay, end of the session. So I will share the feedback link. So in this session, if any feedback means to give that, then go to click the link, then go to give the feedback. Okay. So I share the link in chat box. Wait.
Okay.
ఏది ఇప్పుడు అవసరం Okay, feedback link available in chat box. Okay, so please go to give the feedback. Okay, thank you all. Tomorrow we will discuss. Okay, tomorrow we will discuss the IoT concept. Okay, I hope.
Okay, sir.
Okay. Okay,
Thank you,
all.
sir.
Okay, thank you everyone.
Thank you, sir.
Thank you.
Thank you, sir.